So today we're going to review polynomial long division, and I'm going to go through one basic example in order to do that. So polynomial long division follows exactly the same as normal long division with numbers. There's just, variables involved and you have to know your exponent rules. So what we're going to do is we are going to do 3x cubed plus 8x squared plus 9x plus 10, and we're going to divide that by x plus 2. So some things to take note of, some vocabulary to be aware of. This is the dividend, right? It's the thing being divided. And then we call this thing, the x plus 2, the divisor. And that's what's doing the dividing. So when we set up our problem, we're going to put the divisor on the outside of our long division box. And when the dividend goes on the inside. And when I write my dividend, I want to be careful that my terms are in descending order, so my exponents go from low to high. And I want to make sure that I'm not missing any exponents. So for instance, if I didn't have 8x squared there, if I went 3x cubed plus 9x plus 10, I just got rid of that term, I would put a 0x squared in. So you want all of your terms to be represented. Excuse me. So then all you do is you want to focus on how do you make the first term of your divisor into the next term on the inside of your division box. So in this case, what do I need to multiply x by to create 3x cubed? So the first thing I'm going to need is I'm going to need to multiply by 3x squared. So I'm going to take that 3x squared and distribute it to my whole divisor. So I'm going to get 3x cubed plus 6x squared. And then just like with normal long division with numbers, we're going to subtract down. So I like to put my, what I just wrote down after distributing in parentheses to remind me that I am distributing that minus sign. So I'm subtracting everything. So once I subtract, I'm going to get my 3x cubed minus 3x cubed is going to cancel out, which is exactly what we want. So those are gone. And then 8x squared minus 6x squared gives me 2x squared. And then I'm just going to drop down my next term. And then we repeat that process. So now I want to make x into 2x squared. So in order to do that, I would need to multiply x by a positive 2x. I'm going to take that positive 2x and distribute it through my divisor to get 2x squared plus 4x. And then I'm going to subtract that whole quantity down. So when I do that, 2x squared minus 2x squared is going to cancel. And then 9x minus 4x is going to give me 5x left over. And then I'm going to drop down my 10. So then I'm just going to repeat this process one more time. So now I want x to become 5x. So in order to do that, I would need to multiply that by a positive 5. So I'm going to take that and distribute it to my divisor and get 5x plus 10. Now this one works out really nicely because when I subtract down, both of those terms are going to actually cancel out, right? The 5x's cancel and the 10's cancel. So in this problem, I get a 0 left over, right? And that would be my remainder. So my quotient, my answer to this problem is what's on top of my division box here. So 3x squared plus 2x plus 5 is going to be my final answer. Now, just in case you're doing a problem and you get something that doesn't have a remainder of 0, so there's a number other than 0 there. It can be a positive or a negative value. So if that happens at the end of your problem, if you do have a remainder, you're going to do plus your remainder value. So your remainder value, or whatever the remainder is, and you're going to put that over the divisor. So in this case, I technically have an invisible 10 over x plus 2 fraction on the end of my problem, but because it's 0 divided by something, it goes away. So just as like kind of a word to the